A good day to everyone who's watching. In our lessons of algebra, today we are going to talk about factorization. Now, factorization is just the reverse of an expansion. Remember, when we are expanding, we said we are removing brackets. Now, to factorize is to create brackets or to put back those brackets that we removed when we were expanding. Factorization is the process of writing an expression as a product of two or more terms or expressions. So when I go to the examples, factorize the following. So the factorization is going to be involving the identification of a common factor. When you look at our part A there, someone can rewrite this as 2 times x, then plus 3 times a 2. These are two terms, that is the 2x, and then the other one, which is a 6. They are two terms. So in those two terms, there is a common factor. You can see this first term here, there is a 2, and the second term there is also a 2. So the 2 is the common factor there. So it is the one that we are going to pull out and then create a bracket there. So that is 2 into x plus a 3. When I remove the 2, here I'll be left with x, which is that. Then there I'll be left with a positive 3, which is that one there. Some other person, after identifying the common factor as a 2, you come here, you divide that 2 there, and also divide that 2 on that term there. So now, after dividing there, that factor should be already outside. Now, when I create the bracket, then I come divide that factor by the first term there. When you divide there, you see that you'll be left with x. So I write my x there. Then you divide that one there, you'll be having a positive 3. So some other person can use this one here, this alternative, or the other one there. But you should be able to identify common factors in terms. Here they have given us 2 terms. As we are continuing, you will be seeing that we shall be given 3 terms, we shall be given 4 terms, they can be 5, as many as possible. The part B, when you look at it, we can rewrite it as 4 times x, then plus x times y. When you look at those 2 terms, you can see that x is multiplying the 4, and there also x is multiplying the y. Therefore, the x becomes the common factor. So when I create a bracket, I pull it out, then this becomes a 4 plus a y. When you remove this, it is the 4 that remains, and also when you remove x, it is the y that remains there. So we said that factorization is the opposite of expansion. Remember, when we were expanding, we had this, and then expanded there, saying that this x is going to multiply the 4, and the x is going to multiply the y, which is that part there. Then finally you get 4x plus xy. Our part C, 15 minus 12a. When you look at 15 and the 12, there is a factor of 3 which is there. So this one here, some person can write 3 times 5 minus 3 times 4a. The 3 is the common factor, so I pull it out, then I create a bracket. When I remove it there, here I'll be left with a 5. and then there I'll be left with a minus 4a. The part D, we have 3xy minus 18x. The 3 and the 18, they have a factor there which is common, and that is 3. X here and x there is also the same. That means that also x is a factor there. So someone rewriting this is 3xy minus 3 times 6x. So the 3 and the x, 3 and the x, they are factors. When I pull them outside, I'm going to create a bracket. So 3x into y, then minus a 6 there. Part E, I can first regroup the like terms, 2x and 8x, 4y and minus 12y. So this is 2x plus 8x plus 4y, then minus 12. Then first doing the operation there of addition, that one there gives me 10x. Then the operation there of subtraction, that gives me minus 8y. So now I'm left with 2 terms. The question had given me 4 terms there. When I look at these 2, there is a factor of 2, because 2 times 5 gives me 10 and 2 times 4 gives me 8. So I'm going to pull out a 2, then I create the brackets. So this is 2 into 5x minus 4y. My part F there, when you look at those 2 terms there are 3 common factors. One is a 9, because when you get 27 divided by 9, you get a 3. 18 divided by 9, you get a 2. X here is also common, and there also y is common. So this one here becomes the 9 times the 3 times x times y plus 9 times 2 times x times y times y. When you look at that, I've said the 9 is common. You can see 1x there is common. You can see 1y there is common. So I'm going to pull all those ones out, and then I create a bracket. So 9xy into, here I'll be left with x and a 3, that is 3x, then plus, there I'll be left with 2 and y, that is 2y. We have another bunch of numbers to factorize. So all these numbers here, we are going to be using the identity of difference of 2 squares. Remember, when we expanded in the last lesson, when we expanded this side, we got the other side. Now, if we have been told to factorize this side, we shall always be writing this right hand side. So this is what we are going to be using there in those examples. The Roman one, x squared minus 4, this one is going to be equal to x squared minus 2 squared. When I rewrite this, I can have it that my aim is to make this other part to have a square. So 4 is the same as 2 squared. Then I use this identity here that I have the x there, then the y is my 2. Then now I'm going to write what is the other side. So this is going to be equal to x plus 2, then into x minus 2. Roman 2, 100 minus z squared. This 100, to express it in index form, it is the same as 10 squared, then minus the z squared. Now I'm having a difference of 2 squared. Now I can write the other side, right hand side of that equation there. So this becomes 10 plus z into 10 minus z. Roman 3 there. 8 squared minus 18. When you look at those terms there is a factor of 2. That is 2 times 4 x squared minus 2 times 9. So first creating the bracket to first remove the factor of 2. That one becomes 2 into 4x squared, then minus 9. It does not stop there, because now when you look at a 4, you can write it in index form, and also the 9 you can write it in index form. Then they take us back to a difference of 2 square. Then you write the other part of that equation. So the 4 is the same as 2 squared times x squared, then minus 9 is the same as 3 squared. Laws of indices, they allow me to write this as 2x, and then I put the power outside, then minus the 3 squared. Then now I'm having my difference of 2 squares there, and the x here, it is the 2x, then the y is the 3, then I write the other one there. So this is 2 into the 2x plus the 3, then another bracket, 2x minus a 3. My Roman 4, I'm having 9 minus a plus b squared. The a plus b is under a bracket and it is squared. So my aim is also to make this 9 to have a square. 9 in index form is 3 squared. So this is going to be 3 squared minus a plus b squared. Even these two here, they are difference of 2 squared. When you compare with this one here, the 3 is my x, then the y is the whole of a plus b. So when I write the other part of that formula there, I'll be having my 3 plus the a plus b, then another bracket 3 minus the a plus b. Roman 5, 64 minus 4m squared. This one here, there is a factor of 4 which needs to first be factorized before we continue. So 4 times 16 gives me 64, then minus 4m squared. You can see 4 is appearing there and it is also appearing there. This one is equal to the 4 into 16 minus the m squared. This 16, I'm going to write it as an index number, that is 16 is the same as 4 squared. So this is 4 into 4 squared minus m squared. This bracket here becomes a difference of 2 squared. Now I'm going to use these identities to substitute, write something like that. So this is going to be 4 into 4 plus m, then another bracket 4 minus m. My Roman 6, x power 4 minus 16. Now this 16, I can still write it to the power of 4. When you prime decompose 16, you'll be having 2 power 4 there. So this one here is x power 4, then minus 2 power 4. So both terms there, they have the same power. In laws of indices, this x power 4, I can rewrite it as x squared, then bracket, another power outside. The same applies to 2 squared, then another bracket outside, because when I remove the brackets, the power will be multiplying each other and they go back to power 4. Then these squares outside here, they become, they give me what is called the difference of 2 squared, and I'm going to apply it there. So my x squared here is the x there, and my 2 squared is the y there. So when I substitute them there, I'll be having the x squared, then plus the 2 squared, then into the x squared, then minus the 2 squared. You can see that even this other bracket is giving me a difference of 2 squared. I must also factorize that. So the 2 here squared, I'm going to just write it as 4, then into brackets x plus 2, then into x minus a 2. So another part where we can apply our difference of 2 squared is to find the value of figures there. You need to show that concept of the factorization of difference of 2 squares. Now the examiner can add on something that don't use a calculator, or without using tables or calculator, evaluate or find the value of such a number. So that is when you should know that you'll be using factors to solve such a number or to evaluate such a number. Recalling my a squared minus b squared, that it is equal to a plus b, then into a minus b. My a here is the 100, my b is the 99. So when I substitute, that is 100 plus 99, then into 100 minus 99. So this one, when I add, I'm having 199. Then the other one, when I subtract, I'm having a multiplication of 1. So 1 times anything is that anything. So I get the answer as 199. Part B, I use the same concept. My A is the whole of this, that is 6.51, then plus 2.81, the first bracket, then the second bracket, 6.51 minus 2.81. I have 9.32, then times, when I subtract there, I have 3.7. So I can first write this as 9 3 2 all over 100, then times 37 all over 10. Then now I can multiply the numerator and also multiply the denominator. So when I multiply in the numerator, I'm having 3 4 4 8 4. Then the denominator, I'm having 1000. Then this one here, when I divide, I'll be having the zeros are going to make the decimal place to move 3 times or 3 steps back. So that is 1 2 3. So I'll be having 34.484.